T324 keeping ahead in information and communication technologies. In this course we have ATMA with 20% weight, MTA 30% weight, and final exam 50%. The criteria to pass the course are as usual for AOU. Let's start with the concepts of block 3. So block 3 is ICT systems in context. So we need to investigate ICT system using a specific approach that will be seen in this part of the block. So let's define technical system. So why we are declaring the system as socio-technical system and not only system, because the common understanding of system is that it contains certain set of technical components or technical elements, which is not 100% true, because the system contains social components and technical components organized together to achieve certain or specific purpose or to deliver specific services. So a system is not purely technical system, and this understanding could lead to this wrong understanding could lead to a failure somewhere if we ignore the social impact of the components that affect the system. So this is the definition of socio-technical system that emphasize on both social and technical elements and the organization of these elements together to provide a specific objective or purpose. So the objective of this study is to avoid system failure or to improve the success of the system. So we have started by defining the system as socio-technical system and emphasizing on both parts, which are socio and technical. So we should understand the criteria of system success and failure. Before continuing in depth to say how to avoid such failure. Success and failure are not Boolean metrics that could be used to evaluate the achievement of system. So there is some room for judgment when we say the system is successful or there is some failure somewhere. So the evaluation should not be a Boolean evaluation, okay? And the criteria that should be taken into account when saying we have a successful system or failed system, this should be based on the criteria of function, cost, and timeliness. These three criteria should be taken into account. Function of the system, functionality of the system, or the purpose, or the objective, the performance of the system. Okay, all these terms reflect the functionality of the systems, which should be judged according to what we have declared or what we are expecting from the system. This is the first criteria of success and failure. The second criteria is cost. So cost, or we can say also budget, or the resources that we are expecting to spend in this system. So this is the second criteria, which is as important as the functionality. So we cannot say that the system is successful because it works very well as we are expecting, but we have overspent in the budget a double amount, or a triple amount, for example. So this is also important to pay attention on the cost. The third criteria is timeliness or schedule. Okay, so also this should be respected very well after considering the specification of the functionality and budget. Okay, we have also the time schedule that should be followed very well. So to recap, we have the criteria to evaluate the success and or failure of a system. The criteria are based on three major points, which are the function, cost, and timeliness. So we are going to study how to investigate such socio-technical system. We are investigating a non-existing system. We can investigate a non-existing system to account for the risk of failures. Okay, to pay attention on which things that could affect the success or failure of the system, so that we can take some measures. Or the investigation could be done after the completion of the system, and after even a failure that can be occurred in such system, and the investigation could be could focus on the reason that have lead such system to failure, to overcome this failure. Okay, to redefine the system in a way that solve the previous problems perceived, okay, in the previous system, to improve the system. Okay, so we say that failure is instructive because we can learn the reasons of failures and improve the system based on what we have perceived as problems or reasons of failures. Okay, so it is instructive to learn from existing failure to improve our systems. So we will take many examples about socio-technical system to better understand the approach of investigation. You have in the textbook a case study about the intelligent transport system in UK. So we will see how this intelligent transport system have passed by multiple definition of system, or multiple implementation, or or multiple visions, and each time we have corrected something and forgotten another thing. So, and then we have redefined many times the system in a better way to conclude at the end with a system that has better success than the previous ones. So let's see the way how to investigate a socio-technical system in general, and we'll come back with such intelligent transport system to see this case study and take it as an example for in our case. So as we have said in the definition, we should always look to the system as a set of components. We should focus on both technical and social components, the organization of these components, the interaction between them, okay? And last and not least, the basic operation, or what basically the system do, the basic operations of system, okay, to see if it matches with the original purpose. So as I have said, purpose of a system, objective, output of a system, deliverable, services. So what we are expecting from the system to do, okay, the first criteria of success. So this is very important, and the system should work to provide such output. So we'll keep these notations in mind when going to the different examples that will be studied in this block. To investigate a system, we will draw, first of all, we'll draw a system map. This system map will be obtained when obtaining answers on specific questions. For example, what are the components of the system? So we have a system boundary, and inside this system boundary we will draw the social components, and the technical components. And outside the system boundary, we have some layer, okay, which is not the outside world, okay, a layer that we call environment of the system. And outside the layer of the layer environment, we have the outside world of the system, okay. So the environment layer contains the components that affect the system or can be affected by the system. So it's important to know the environment components, since they could affect the system or can be affected by the system. So this is as important as to understand what are the internal components of the system. So we start the system map by identifying the internal components of the system and the environment components of the system. We can group such components together in subsystem if they are related to each other in some way, okay. So we can have some hierarchical diagram of system and subsystems for a better representations of the system map. We should pay attention when identifying the components of the system and the environment component to search the technical component and the social component, because both have impact on system success and failure, okay. For example, we have the stakeholders, which are the people or group of people who have interest or stake in the working of the system. Okay, so stakeholders does not represent, okay, one person or one group. Stakeholders represent multiple social components that could be part of the system. Once we have identified and drawn the components of the system and the environment components, it's not enough to say that the system contains such and such and such elements or components. We have said that the system contains social and technical components organized together, interact, organized, work together to achieve certain specific purpose. So we have, after identifying the components, we should identify the processes, the flow of information inside the system, okay. So each process having an input that then we have some flow of information between multiple components to end finally with an output. So this is a process. So what are the processes of the system? This is very important to know, to understand how this system works. How this system works, and not only what are the components of the system. So these components could be worked together or organized together in different ways, in good ways or bad ways. So what are the processes of our investigated system? This should be identified, drawn arrows that are circulated between components, okay, to provide more information or deeper information about the system on the system map. A system map containing components and drawing the processes does not mean that we have complete knowledge about the system. For example, if we take the idea of emergence, so the emergence means that the whole being more or less than the sum of the parts is given such concept. Okay. Different definitions are given to such concept, but maybe these are the most used definitions. So emergence is an overall system behavior that comes out of the interactions of many participant behavior that cannot be predicted or even envisioned from a knowledge of what each component of the system does in isolation. So an example of emergence is the traffic jams that appear on motorways sometimes without there being any obstructions in the carriageway or any other obvious reason. So this is not a normal process that we have identified in the system map, but we could have some emergence cases which is not predicted. So the experience have led us to think that the non-consideration of the social parts of the system have led many times to system failures. And systems rarely fail for purely technical reasons according to the previous experience, but to some other reasons which are as important as the technical reasons in this case. This is a common misunderstanding in the previous decades. The awareness that should be revealed in this part is to think about the other part, okay, or about the combined factors plus people, to the part related to the human being. Okay. So problems as delays, overspending, unrealized promises, dissatisfaction, etc. Such problems do not occur always due to technical reasons. Okay? Many other reasons could lead us to such failure. So let's emphasize on the impact of people involved in the situations of the system and on the interface between people and technology. as well as the technology itself. So if we review the recurring themes in poorly performing projects, we can have deficiencies in the organization structure, inadequate design, deficiencies in the performance of one or more subsystems, lack of an effective means of communication between the various systems, lack of clarity of purpose, very important. It's very important. Okay, lack of clarity of purpose. We could have a system which does not match or which behave or which the operation of the systems, the functionality do not fit exactly with the purpose, with the real purpose of the system. So this could lead to failure, although it could work properly, but not for the original purpose. So we could have also not enough consideration given to the influence of the environment. This could lead to affect the success of the system, or imbalance between the resources applied to the basic conduct of the project and those allocated to the related monitoring and control processes. If we want to make some grouping of critical failure factors, we could have, for example, organizational context could affect the success of the system, as hostile culture, poor reporting structures. Okay. Other group of critical failure factor could be management of the project. If we have some overcommitment or political pressures, so this could be used to judge some failure in the system because we have overcommitted, for example, its purpose or deliverable. Other group of critical failure factor, conduct of the project. So in the initiation phase, we have technology focused lure of leading edge. In the analysis and design phase, could have poor consultation design by committee, technical fix for management problem. In the development phase, we could have staff turnover, lack of competencies and communication. In the implementation phase stage, we cannot have receding deadlines, inadequate setting, and inadequate user training. These are common reasons of failure or failure factors. So as we can see clearly in the previous failure factors or reasons of failure, that failure could be due to many reasons which are related to people and technology. Okay. So we should look to socio-technical systems as, or to the existing ICT systems. We should not look to the ICT system as technical system, but as social systems that use ICT. Okay, so if we look to the ICT system as purely technical systems, this could lead to system failures to the reasons that we have mentioned. We have many reasons which are not related to the technical part and could lead the system to failure. So we should look at ICT system as social systems that use ICT and take into account the reasons of failure that we have mentioned before to improve the system success and consequently avoid any potential failure. To this end, we will use a set of system questions which could help us to draw the system map and even to understand many things which are not shown in the map, which could be behind the system map, so that we can reach a deep understanding of the system or deep investigation of the system that could help us to account for the reasons of failure or identify the potential risk of failures. So we have system questions about the components and the environment, the processes of the system, the structures. We have technical questions as well, but as we have said, we shouldn't have only technical questions to investigate the system. We have pragmatic questions, total or basic questions, decision policies, and the future. So, for example, we can have questions about the system and its environment as, can you suggest a name for the system you have selected? What are its components, the components of the system? What are the components of its environment? What interaction does the system have with its environment? What wider systems influence this system? What interaction does the system have with its wider system? So these questions are helpful to draw the system map, and these questions as well could help to complete the system map with the processes by asking about the system's input and output, the flow of informations of the systems, and even more things that could provide more information about the processes, as how are the processes controlled, what measure of performance are used, what resources are needed to carry out the processes. So these are very useful questions to investigate the system. Also, we have questions on structures, add the following ones. Technical questions are also important, as what technology does the system use? What are the codes of practice? The relevant ones. Is the technology mature or novel, old and obsolete, new and untested? These affect the success and failure. How long will it be stable? Are there maintenance or updating implications? We should consider all these questions to avoid failures due to technical problems. Are there reliability or safety issues? Okay. For example, if we have an online payment system, so is it reliable? We can trust to pay by such system. We can use our credit card number to pay, or it's unsecure. So this could affect the success and failure of the system. We should investigate the system by asking these questions and avoid any failure that could be due to such reasons. Does it require new skills to be developed, for example, by existing staff? What are the interfaces between the people and the technology? So the interface are helpful or confusing, or could have some misunderstanding or not. So we have the questions that can help us to draw the system map, but the investigation could be deeper and deeper by asking technical questions, pragmatic questions. Okay, as for example, what special or chance event have occurred recently? How did they affect the system? What relevant external changes or innovations are likely? Are there any particular personalities or other special factors at work? How good is the fit between the technical system and the politics and culture of the organizations? Does the system raise ethical issues? Okay. So we have more and more understanding and investigation that are not shown even in the system map. Total or basic questions, very important. It's very important to ask what basically does the system do. So the basic operation of the system, what does it deliver? To see if we have achieved our purpose or not. What gives the system its identity? What are the main objectives? Can the achievement of the system objectives be measured? To what extent are the objectives met? What is the capacity of the technology to meet users and customer needs? What are the main conflicts? What is the balance of power? Other questions on decisions, policies, and the future. How is the system likely to behave in the future? How is it possible to implement changes? So, is it scalable, our system, or not? Okay. On what criteria can one decide what change is desirable? Whose values determine what is desirable? Can continue reading the articles about intelligent transport system to understand this case study, which could provide you better understanding of the investigation of socio-technical system. Other examples can be found on Moodle about existing socio-technical systems as e-learning system or student online registration system. You can find many examples to understand this approach. So you can read these articles and try to make an investigation, draw the system map, and understand even more things that affect the success of system, that which is not drawn in the map, by asking the systemic questions